always love when the gentleman's on the phone with us. Professor Andrew Fraknoi. Whenever there's things happening in space, in our skies, that we get him on the phone to talk about it. And well, first of all, good morning, Professor.
Good morning. Nice to be back with you.
Always a pleasure. Three great subjects to bring up today. The first, the new discoveries about Saturn's big moon Titan. Now, this is pretty huge because it has an atmosphere thicker than Earth's.
That's right. This is perhaps the strangest moon in our solar system, orbiting Saturn, and it's bigger than two planets, bigger than Mercury and Pluto, and it's got a thicker atmosphere than Earth, and it's quite cold. So the environment is very, very different from the Earth, and yet it reminds us in some ways of the Earth. Here on Earth, I think many of your listeners know, water can be in three different states. It can be a liquid water, which we drink. It can be water vapor in the clouds, or it can be solid ice. On Titan, methane, swamp gas, has that same property.
So it's a pretty stinky planet then, right?
Well, it is, and it's full of other products like hydrocarbons and ethane and other kinds of weird things, but they can be liquid, gas, and solid. And so the big discovery is that we have actually found lakes of liquid methane, lakes of swamp gas, there on this moon under the thick atmosphere.
Liquid lakes. Now, of course, unless you're religious, man came from the water. Is there life on Saturn?
Well, this moon Titan has a temperature of minus 290 degrees Fahrenheit.
So you'll need a jacket.
Yeah, you should bring your thermal underwear. I thought maybe this was a place to bring your honeymoon couple, given what happened. Anyway, it's not a likely place for life as we know it, but of course there's always the possibility of life as we don't know it.
Now, Professor, we sent a probe, Cassini, right, to this moon.
Part of the Cassini probe, you're right, called the Huygens probe, actually landed on this moon and found that on the moon there were not only dried up riverbeds of methane, but that the rocks were made of solid water. It's so cold, the water rocks are harder than rocks on Earth.
Wow. That's pretty cool.
Exactly.
That was a pleased scientist laugh right there. This is very interesting to me. I hadn't heard about this. There's a controversy about NASA not having enough money to help protect us from killer asteroids. Of course, some trains of thought are that asteroids are the whole reason why the dinosaurs went extinct. Some are saying it may be 100 years, it may be 1,000 years, but Earth will be hit by a huge asteroid to cause all sorts of Armageddon-like damage. What is this about?
Well, one of the things that we've discovered in recent years is that the asteroids are not well behaved and confined to a belt between Mars and Jupiter, like we all learned in school, that there's a belt of rocks that is between Mars and Jupiter. Turns out some of these rocks are loose and are flying around the solar system, and some of them cross the Earth's orbit. And since a number of them are dark and small, we don't know how many of these Earth-crossing asteroids there are. So NASA gave astronomers this assignment. Will you guys please find all the asteroids that can possibly cross our orbit and maybe hit us someday? And this assignment turned out to be a lot harder than we thought, because even smaller chunks of rock could cause significant damage. A small chunk of rock hitting and exploding over Los Angeles, for example, could kill millions of people.
When you say small chunk, the size of, say, a Volkswagen or a larger?
Or the size, well, for astronomers, small might mean a mile across, 2 miles across, half a mile across. Those are small chunks of rock and not that easy to see at large distances. So we've been given this assignment to catalog all the possible asteroids that might be dangerous. And then NASA's begun to have other priorities and is not putting enough money into this. And it's going to be a tough job finishing it up unless we put more resources into this and perhaps less into building some crazy base on the moon.
With all your knowledge and all you know, in your opinion, and this is just conjecture, will the Earth be hit by that size of an asteroid eventually, someday?
Well, definitely someday. The question is when. 65 million years ago, as you say, we have now pretty good evidence that a giant asteroid, maybe about 10 miles across, hit the Earth and the environmental consequences of the explosion, the great amounts of dust lofted into the atmosphere, made a kind of darkness and a winter for over a year.
Wow.
And killed many, many of the species living here. But that was 65 million years ago. And we may not get another one that big for 1 million years, which, is beyond what I can think about.
Yeah, but I mean, 65 million years ago, they didn't have Bruce Willis.
There you go.
Now,
by himself, he did that.
Yeah.
What a nutty movie.
Professor, let's talk about that. Let's say that we are on a crash course with an asteroid. What can we do about it?
Well, and this is the good news, is that both scientists and the military have been taking this very, very seriously. And there was just recently a conference where the two groups got together, and there's encouraging news. If astronomers can give like 10 years or 20 years warning, which we think ultimately we can, then the military can do things about it. They could, for example, nudge an asteroid aside, use some kind of nuclear weapon or a rocket to push it aside slowly and to have it miss the Earth.
Wow.
So this is not out of the question that we, unlike the dinosaurs, could save ourselves.
All right. Now, I'll be the idiot here and just say that, I love space and all the exploration involved, but I've never been able to understand what a black hole is. And there's been new discovery of thousands of other black holes out in space. Try, if you could, to explain to me what it is.
All right, let's see if I can do this in a few well-chosen words.
Okay.
I like to tell my students that a black hole is a squozen star. Just like you have fresh squozen orange juice, this is a squozen star. At the end of its life, some of the biggest stars simply collapse and collapse and collapse under their tremendous weight. And they become so squozen, they become so strong in gravity, that nothing can get away from them, not even light. And if they become so powerful in their gravity that not even light can get away, what color will they be? They'll be black.
I don't understand how a strong force of gravity can attract or diffract a light. I don't understand how that a light can bend from gravity.
Well, this actually is a very profound question that you're asking about. And this was one of the great discoveries that Albert Einstein made. It's called the theory of relativity. That
I've heard of that.
Space and time are not independent of the stuff that makes up the universe, but that the two are kind of have a relationship. Stuff, gravity, and space and time are married in a way, and when gravity gets very strong, space and time are affected. Now, this is something, it takes me 2 weeks in my introductory astronomy class to explain in detail, so
yeah.
I can't do it in 10 seconds on the radio, but all kinds of experiments have now shown that Einstein was right. And here's the interesting thing. First of all, black holes are far away and they're no danger to the Earth. Let's reassure our listeners right away that these collapsed stars are rare, they're far away. But if such a collapsed star can form in the middle of a big island of stars like our Milky Way galaxy, then these enormous gravity sinks can swallow up other stars,
Wow.
loose gas, asteroids, and grow. And we can have black holes that already contain millions of stars worth of stuff. And that's what we found. We found thousands around the universe, far, far away from us. We found thousands of giant black holes, each sitting in the middle of what's called a galaxy, an island of stars.
Right.
And each of them having swallowed millions or billions of stars in that central region.
All right, Professor, going back now, bending light with gravity, can we on this Earth create enough G's, enough G forces in a controlled environment to bend light?
Yes, slightly bend light, we can. In fact, we can watch light bend near the sun. We've done eclipse expeditions when there's an eclipse so that we can see the light from stars coming by the sun because the sun is dark. We've actually watched the gravity of the sun bend light. That's how we proved this theory the first time. And every eclipse we do this. We check out how much the gravity of the sun bends light. Here on Earth, we can, in fact, with very, very clever experiments, show that this works down to a tiny fraction of an inch. But in black holes, the bending is far greater. That's the difference.
Now, Professor Fraknoi, when you were talking about the black holes, you were saying that their gravity affects space and time. You're not getting into time travel in there, are you?
You are, indeed. This is one of the things my students have lots of fun with, that because the structure of space and time has changed, time near a black hole actually slows down. So that if you were to go to a black hole, you could actually live longer. Your time, your growth, the ticking of your heart, every process by which you measure time near a black hole would slow down, and you could live longer. It would be a sort of fountain of youth.
Yeah, but you're at a black hole.
Yeah, but that's right. You'd have to not fall into the black hole and survive the tremendous pressures near it. I'm not recommending this as a rescue right now.
Good safety tip. Good safety tip. This is great. This is, I think, and I always love you on the show. I know my partner does too. And this is probably one of the coolest conversations we've ever had with you.
Yeah, it's a very good one.
Well, thank you so much. I love these kinds of subjects, and I want to encourage your listeners, if they're interested, to take an astronomy class at a community college like the one where I teach, or do some reading, go on the web and explore some of these topics, because we're discovering just remarkable things about the universe, and it's everybody's birthright. Everybody gets a chance to share in these great discoveries.
Listen, Professor, and I know you get comments from your students, I'm sure you do, and saying just how great a teacher you are, but you just said what I was just thinking. You make people want to read a book. You make people want to, take a class.
Well, thank you very much. I so much enjoy it, and I enjoy talking with you guys about it. It's fun to share what we're discovering.
Do you know what's even more dangerous to live near or around than a black hole?
I shudder to ask.
You can use this in your class. A Jack black hole. That you don't want to be anywhere near that, especially after a Taco Bell.
All right, well, that is why he's a regular on this program, Professor Andrew Fraknoi.
You're awesome.
Professor, thank you.
Thank you for having me.